control surface flutter can affect the ailerons, the elevator and the rudder. Of the three, we will consider aileron flutter, being perhaps the easiest to visualize. The movements shown are deliberately exaggerated for clarity. When an aileron is deflected downwards into the airflow, an aerodynamic force will be generated, acting upward at the hinge line. This aerodynamic force will twist the wing about its torsional axis and start to wind up the wing like a spring. Because the CG of the control surface is aft of the hinge line, and because there is always a small amount of backlash in the control system, when the wing twists, the aileron displacement will be increased slightly. The increased deflection of the aileron will give an increased twisting force to the wing. This set of actions will repeat. Eventually, the rate of wing twist will decrease and the aileron will start to catch up with the twisting wing, and then the whole process will reverse and become divergent. The result of aileron flutter is here illustrated. Clearly, this is unacceptable and must be prevented. Don't forget, this can occur with the rudder and elevator too. The pilot cannot prevent flutter. Even if you hold the cockpit controls rigid, backlash in the control run will still allow the control surfaces to flutter. Even power flying controls have some backlash. You might think that to reduce control surface flutter, the wing could be made stiffer to stop it twisting. Theoretically, yes, but no structure is absolutely rigid, and increased stiffness increases structural weight, something to be avoided. Remember, reducing flutter is not acceptable. Flutter must be prevented. The control surfaces themselves must have their mass redistributed to prevent them lagging when an input is made. This is called mass balance. To prevent flutter, the CG of the control surface is moved forward onto the hinge. You can see that the force on the hinge line still twists the aerofoil, but there is no increased control surface deflection. A weight is added in front of the hinge to move the CG of the control surface forward onto the hinge line. To minimize the size of the mass balance weight, the weight is sometimes mounted on an arm, as illustrated. When possible, the mass balance weight is mounted inside the aircraft structure to minimize drag. If possible, the presence and security of mass balance weights should be checked during the pre-flight walk-round.